Hello, trigonometry. This is a short video lesson on the law of cosines. So we saw the law of sines was a proportion setting the ratios between the sine of an angle and its opposite side equal. The law of cosines is a modified version of the Pythagorean theorem. It's based on the same concept where you could take a non-right triangle and divide it into right triangles and use the Pythagorean theorem along with trigonometry to create these equations. For the shortness sake, we are just going to jump into using these problems. You can see that there are three versions of the same equation where the letters of the triangle are just in different orders. Ultimately, these are all the same function because the variables are arbitrary. It could be any letter. But for the sake of this problem, we want to look for two things. Either we're given an angle, and that's going to determine what function we have, or we're only given three sides and no angles. These are two good clues that you're going to be using the law of cosine. Since we've got angle C here in this problem, we're going to use the version of the formula that says C squared equals. Remember that C is the side across from angle C, A is the side across from angle A, and B is the side across from angle B. So these problems tend to be the more simple version of the law of cosines when you're just solving for a missing side. We're going to set it up as C squared equals A squared, and you can see these sides are given to the nearest tenth. So we're going to keep our answers also to the nearest tenth so that we're using the same numbering strategy. 0.3, just trying to write this all in. We're just plugging this in. Oh my gosh, I'm gonna run out of room. Can I just slide that over? Okay, cosine of 82.2. Oh no, it didn't work. Okay, just pretend that you can see that. So when we're doing this, we really need to follow PEMDAS. We're gonna start with our exponents. So we're gonna say C squared equals, and we're going to go ahead and do 24 squared plus 26.4 squared in our calculator. So 24.3 squared plus 26.4 squared, and that gives me 1,287.45, and I'm not rounding that. Minus, now I can get into my multiplication. So I'm going to switch colors to just plain black, and I'm going to multiply all of that together. So that's 2 times 24.3 times 26.4 times cosine of 82.2. And so that gives me 174. This one is rounded, so I'm actually going to store this in my calculator. ... And so when I type this in, I'm just going to use that ANS answer feature. I'm going to type 1287.45 minus the previous answer, which gets me C squared is equal to 1,013.32. That's rounded. So again, when I go to take the square root, I'm going to take the square root of the previous answer, which gives me a side length of about 33.4. And that's our first answer. Now, once you've got this first side, you're really not using the law of cosines anymore. So if I were asking you a test question just on the law of cosines, this would be it. Find side C. However, if I was asking you a question and I wanted to include both law of cosines and law of sines, after finding side C, I would also ask you to find angle A and angle B. So for this example, because the alphabet is cool, let's solve for angle A. We're going to revert to the law of sines that we saw in the previous video lesson. Sine A over the opposite side is equal to, and pick the angle we were given, which was C. So sine C over the opposite side that we just found. With this particular setup, we need to multiply both sides by 26.4 to get our solution. So we're going to do sine of 82.2 divided by 33.4 times 26.4, and we get that sine A is equal to a decimal, which makes sense because it's a ratio. So we've got 0.7831 ... and I'm going to do inverse sine of the previous answer, which gives me an angle of about 51.5 degrees. Once you have the first two angles, you no longer need the law of sines or the law of cosines to find the third angle. Just add and subtract from 180. So that gives us the remaining side as 46.3 degrees, and we have solved this entire triangle. Let's head down to a slightly more complicated law of cosines example. We're given all three sides. It's very important when you are solving this that you always solve for the largest angle side first. This is going to avoid any potential ambiguity. You saw the ambiguous case with the law of sines in the previous video where you could have 0, 1, or 2 answers. We want to avoid that. When you have all three sides, you should be able to get exactly one answer. And the best way to accomplish this is to find the largest side and set your equation up using that side. So we've got 26 squared equals 14 squared plus 18 squared. And the order here doesn't matter because addition is commutative. 2 times 14 times 18 cosine of b. When we're solving, again, we want to follow PEMDAS. So I'm comfortable doing 26 squared first, which gives me 676. And then I'm going to go ahead and combine 14 squared plus 18 squared. And that gives me 520. And then multiplication, I'm going to do 2 times 14 times 18. And that gives me minus 504 cosine b. From here, you absolutely cannot subtract or combine these two terms that you have on the right side. Our variable is attached to the 504 as a coefficient, and we need to solve this equation by doing operations to both sides. So we've got 676 minus 520 equals negative, don't forget that negative, 504 cosine b. I am going to not divide these and get a decimal. I'm going to leave it as a fraction. That way I can guarantee the most exact and precise answer. From here, if you didn't know it at the beginning of the problem, you know it now. We are solving for a missing angle, and that means we need inverse trig. So we're going to type into our calculators the inverse cosine of negative 156 over 504. That gives us that angle B is 108.03, which we're just going to round to 108 degrees. From here, again with the law of cosines, the first step is law of cosines, and after that, if you're asked to solve the entire triangle, every other step after this is going to be law of sines. So to find the missing angle A, we're going to set up a sine ratio, which is going to be sine A over side A, 18. And then the only other angle we know is the 108. So we're going to do sine of 108 over 26. To solve, we're going to take the inverse sine, multiply the 18 to the other side. So that's 18 sine 108 over 26. And we can actually get this all in one go by directly typing it into the inverse sine. Just make sure you're closing the parentheses in the right places. So like my calculator opens a parentheses here, and I need to shut that before I hit enter. So if I'm rounding, this is about 41 degrees. Finding the other side, I just need to take the two angles I know and subtract them from 180, and that gives me 31 degrees for the remaining side. 31 degrees. So this concludes the video notes for law of cosines. With this lesson, you really need to understand the law of sines first because that's how we completely solve our triangles. Now you'll notice in these video notes, there were no real world problems. So make sure you're practicing examples that include a real life scenario or setup or word problem. And I believe Moore gives you a few good examples of that, but I'll also post a couple good word problems through Canvas for you to practice. Thank you for watching.